Hello and welcome to the lab portion of our class. The lab is where we build a game. In each lab I provide some starter code for you to work on and you add to it, building up a game. As the lessons progress, hopefully you'll add more and more code to it and build a game. At this point you have a choice. Do you watch this video first or do you access the lab? Here we go. Here's the lab. Here's your instruction on what I want you to do with the code. There's an image you download to do this lab, and there's the code or the starting code for this lab. What this video is going to be is an explanation of that starter code. So whether you read over the lab first and then watch the video, or watch the video and then read over the lab, that's up to you. But here you go. One thing this lab instruction wants you to do is download this image. I'm on a Windows computer, so if I right click on the image, I can say save image as. Make sure that you store the image in the same folder that you store your program. The same folder where you put your HTML file, put your image in that exact same folder. I'll go ahead and save that image, and I've saved that image to the same folder I plan to copy and paste this HTML to. See this code right here? That is our lab program. That is the start of our lab program. I'm going to copy and paste that code to the exact same folder I copied that image to. So that's what this video is going to be, is explaining this code, showing you the various pieces that make it up. Now one thing you'll notice about this lab code is we're not going to try and repeat too much from previous labs. In the previous lab, we talked about the header at the top of the code. I'm not going to talk about that every time. I'll go ahead and do the canvas tag one more time here. Here's the canvas tag. This is the last time I'm going to talk about the canvas tag. I've already covered it once. Here's the second time covering it. I'm not going to at every lab go over the canvas tag because it's basically the same canvas tag every time. This is the HTML5 portion of the file. Canvas is a tag that was introduced with HTML5. It's designed so that you can use JavaScript to draw and write things to the canvas. It is a requirement that the ID be set to my canvas. We have to set the ID to my canvas. When we look at the code below, you'll see that we are depending on the ID being set to my canvas. It means it's 800 pixels wide, and this means it's 600 pixels high. Basically going to build our game on an 800 by 600 canvas. Our game window is going to be 800 wide on the x-axis and 600 tall on the y-axis. The style here is just to provide a border. We want a 4-pixel border in a solid red outline, so you can see the outline of the game. When we're under mouse control, that'll be the area that affects our mouse control. This warning, no HTML5, upgrade your browser. It is a requirement of this course that you have a web browser that supports HTML5. If you do not have a web browser that supports HTML5, this message will show up when you load this web page, and you definitely need to upgrade your browser. Prefer Firefox. We'll use Chrome. Try to avoid things like Safari. Firefox and Chrome are the recommended browsers for this thing. This is an HTML5 command. That's the end of the canvas tag there. By this point, you should be getting used to this canvas tag. Like I said, this is the last time I'll cover it in the lab. Next up is the script tag. The script tag says I want to stop coding in HTML and start coding in JavaScript. So this is essentially the start of our JavaScript. This is an HTML tag that says switch over to JavaScript. And from this point until we hit the /script tag at the end, we will be coding in JavaScript. Now there's a set of variables here. These are called global variables because they're going to be available to the entire program. There's a set of variables here that's what you're going to be doing during this lab. You're going to be messing with these variables, changing their values, seeing how it affects the game. X and Y. What are our coordinates on the X and Y axis? We're building a 2D game, a two-dimensional game here, and we have an X offset and a Y offset. Notice the value I set here is 400 and 300. That is roughly half of the 800 by 600. I'm trying to start my character roughly in the center of the screen. X and Y, as you can see, are very, very short variable names. In this case, everyone that's ever programmed a video game understands X and Y are coordinates. They're coordinates on the screen. So in this case, X and Y, very short variable names, are acceptable. I do not want you using very short variable names throughout the rest of this code. When you declare a variable, I want to make sure that you declare it with a name that describes what it holds, what it does. X and Y is clear to everybody. It's the X and Y coordinate in two-dimensional space. But for the rest of the variables, make sure that you give them sound descriptive variable names. The other thing I'd like to encourage you to do here is do what I call declare the variable. See that var in front of X? See that var in front of Y? That's not a requirement. JavaScript doesn't say you have to do that, but I'm going to do that because in other programming languages like Java, C++, C#, you have to declare your variables. When I started coding this game in HTML5 and JavaScript, one of the things I was planning to do is rewrite it in Java, and I quickly realized if I'm going to upgrade this code, if I'm going to recode it in Java, I want to code in a Java-like manner. So I'm going to make a rule here that we have to declare our JavaScript variables using the var keyword. Be sure when you're declaring a variable to put var in front of it. Just like I'm going to ask you to put a semicolon at the end of each executable line. Again, that's not a JavaScript requirement. All these semicolons are optional. But as soon as you try to program in another language, you're going to be required to put those semicolons in. So let's just get into the habit. It's not a requirement, but let's build this code like we want to learn other programming languages. So let's always use the var when declaring variables. Let's always put a semicolon at the end of an executable line of code. The only thing changing these two numbers will affect is where your character starts on the screen. If you were to change this to 0, 0, 0, 0 is the upper left corner of the screen, so your character would start here. Play with that. When you get this code up and running, play with different starting positions and just see where your character shows up. Next up is speed X and speed Y. This is the speed we want our character to move. Notice the much longer, clearer variable names. This is speed on the XY axis we want our character to move. This is the speed on the Y axis we want our character to move. And basically we're saying we want to move 5 pixels at a time. This is the amount we want to move on the X axis and the amount we want to move on the Y axis. Right now, per the game engine below, this only affects keyboard control. When you say I want the keyboard arrow keys to control my characters, this is the amount each key press. So if I hit the left or right arrow, I will move 5 pixels on the X axis. If I hit the up or down arrow, I'll move 5 pixels on the Y axis. These two variables only affect keyboard access for now. Next up is a very important variable. Var file name equals mario.png. It's the name of the main character of our game. The main character, our hero if you will, it's got to have an image file. We have to have an image on the disk which represents the character we want to play. Right now I've decided to name that file mario.png. That was the image we downloaded just a little while ago when I had you right click on it and save as. Just make sure that this name matches the file in the same folder, the same directory as your HTML file is. If you give it the correct name of the file and if it's in the correct folder, this code should be able to display it on the screen. If you wish to change the character, if you wish to change the main character of your game, you can either overwrite this file mario.png with a different file, or you can save a different character into your directory and change the name of the file. Feel free to do that as an exercise. Download or find an image somewhere of something, store it as a different file name in your folder, and change this file name and see how the program loads a new one. Var mouse equals true. This is what we call a Boolean variable. File name was a string variable. Speed X, speed Y were integer variables or number variables. But mouse is a Boolean variable. We can assign it true or false. When mouse is set to true, we're going to use the mouse to control our character. And when I move the mouse around the screen, the character will follow the mouse. If I set this variable to false, we want keyboard control, and the character will move when I hit the up, down, left, and right arrows on the keyboard. Play with this value. Set it to false and see how you can move the character with the keyboard. Change it back to true and see how the character follows the mouse. Next up is what we call the refresh rate. How often do we want to redraw the characters? This 34 is in milliseconds. Every 34 milliseconds, I want to redraw the screen. That works out to about 30 refreshes per second. So 30 times a second, we're going to be redrawing the screen. It's probably a little easier to see if you try this with a value of 1,000 for the refresh rate. 1,000 milliseconds equals 1 second. If I set this variable to 1,000, it means update the screen once a second. Now obviously that's pretty clunky for a real video game, but while you're playing with this code, try different values and see how it affects how often the character gets redrawn on the screen. To be honest with you, about the smallest you want to go on this value is 17. 17 mathematically works out to about 60 times a second. Since a browser can only refresh the screen about 60 times a second, 17 is about as low as you want to go there. But play with different values and it'll affect how smooth the animation is and how often the character gets redrawn. I'll point it out again when we get down to the code that draws the screen, how often that's going to happen. But 34 is an amount that says redraw the screen about 30 times per second. Now, one of the ways I'm going to teach you about game programming is show you how game engines works. I'll be honest with you, today in the real world, when you program a video game, chances are you're going to be using a game engine. You're going to be a game engine like Unity or Unreal Engine or Game Maker. There's several game engines out there on the market, and almost no one programs a video game from scratch. They all start with a game engine. But how does a game engine work? How does a game engine do what it does? Since this is a beginner programming class, if we just jump straight to a game engine and it does most of the work for you, you're not really going to learn how game engines work. So what we're going to do in this lab is we're going to build a game. I'm going to provide the game engine. My code below this line will be the game engine. But it's going to be very, very simple to begin with, and we're going to build on it as we go along. And what I'm hoping to get you to understand is how a game engine works. For those that know how game engines work, can program better video games. If you just let the game engine do all the work, then you're not really learning things. So I'm showing you from scratch how to build a game engine, and hopefully you'll understand the structure and the format of how a game engine works. But basically it works like this. When you use a game engine, you write part of the code and the game engine writes the other part of the code. Below this line will be that other part of the code that's provided for you. For this lab, I only want you changing these variables. Don't change anything other than these variables. Don't go down into the game engine code below and start changing it. There'll be plenty of time to upgrade it in later labs. This is the beginning. This is a start. Leave the game engine alone. I've broken this up into about 3 pieces. If you go back to the original lab screen here, you can see that this is not going to fit on one screen. So what I did is I broke it up into 3 pieces. There's the beginning. Now we got to go to the middle, and there'll be a third slide when we get to it. So this is page 2 of 3 for the lab assignment. This is the game engine. See this right at the top? That is a JavaScript comment. This is the game engine. I do not want you changing this code. I'm explaining it so you understand how a game engine works, how a game engine operates, but I don't want you changing this code. First up, there are going to be some global variables for the game engine itself. All those variables we declared above, X, Y, mouse, refresh rate, those are global variables that you, the programmer, have access to and will be changing and updating. These variables here are the game engine's variables. I'm going to explain them. I want you to understand them, but I don't want you changing these variables. These are the game engine's variables. Let's try and leave them alone. First up is our var canv, C-A-N-V. This is short for canvas. This is the variable that's going to let us access the canvas we looked at on the previous slide. Remember that red border around it? I said put a border around it. That's essentially the canvas. You can see it when you run this code. When you see that red border around it, that's the canvas. The second variable here is canvas2D, which is the two-dimensional context in which we're going to draw things on the screen. Basically, the canv is for accessing the whole thing. What's the width of the canvas? What's the height of the canvas? Canv2D is for drawing on that canvas. Var myImage. MyImage is our main character. It's the main character of the game. On the previous slide, file name Mario equals PNG. Mario.png is the image. I need a variable to keep track of the image on the screen, and this is it. And again, this is a game engine variable. You shouldn't be messing with that. Let the game engine do the work for you. That's how game development works these days. The game engine does most of the work. You, the programmer, just customize what shows up on the screen. These three variables are very, very, very important. I want you to understand what they are, but I don't want you changing them. I want you to change the global variables above for this lab. Next up is what we call a function. It's a chunk of code that runs. In this case, it's going to run every time the web page is loaded. See that window.onload there? Every time I load this web page window, run this code. Even if I just hit the refresh button or the reload button at the top of the browser, this code will run. About the only thing that runs before this code is those variables that we declared at the top. Remember when we said x equals 400, y equals 300? That executes prior to this code, but immediately following the variables, this code will run, and it will run every time the page is loaded. So the first thing we're going to do is we're going to say canv equals document.getElementById myCanvas. Wow, how important is that? Remember how I said make sure on that previous slide you use an ID of myCanvas? There's the ID of myCanvas right there. This is a requirement that the ID has to be myCanvas. If you use a different canvas name, you would have to change that. But I don't want you changing this code, so keep the ID in the HTML5 tag myCanvas, and that just basically says this is where we're going to write our game. This is where the code for our game is going to display images on the screen. One way to think of the canv is it's the outer edge of the window. It's the outer edge of the canvas. Next up is the canv2d equals canv.getContext2d. This is going to be a two-dimensional game. It's going to have an x-axis and a y-axis. And what we're doing here is assigning to a variable a context, a two-dimensional context. Everything that we draw in our game window, everything that gets drawn inside the red box is going to be through this canvas2d variable. Remember, these are global variables. We set them up once at the beginning, and then we'll use it throughout the code all over the place. Anytime I want to write a picture to the screen or a word to the screen or an explosion to the screen, it's going to go through this canv2d variable. Boxed out two lines of code here because these two lines are very related. MyImage equals document.createElementImg. What we're doing is we're dynamically creating an image in computer memory. I'm then going to say myimage.src or source equals file name. This is what triggers downloading of the image. Remember our Mario character. Coming back to our web page over here. Remember the Mario character right there. That is what loads that into our JavaScript program. I want to load this character into our JavaScript program. This line of code says load mario.png. File name was set to mario.png. This will load mario.png. If you change the file name, if you substitute in your image, then it will load whatever file name was set to. So make sure you get that name correct. Also make sure it's in the same directory as your HTML file. See what the engine's doing? The engine's doing a lot of the work that is consistent from game to game. You always have to set up a canvas. You always have to set up a 2D drawing area. You always have to load the image of the main character. Why make programmers repeat that code over and over? If the engine can do that work for you and it's the same every time, let the engine do the work. All you have to do is set the file name properly and it will load up the image for you. Next up is what we call an if-else statement. This is what's going to determine whether we use keyboard or mouse. If mouse, remember mouse is a true-false Boolean variable. If the mouse value is true, it will execute this code canv.addActionListener MouseMove, MouseMove. Basically, this is what we call event-driven programming. Whenever the mouse moves, call this function MouseMove. This second parameter is a function called MouseMove. We'll see it on the next screen. Every time, see, my mouse is moving right now. See how the cursor is moving? Every time the cursor is moved, I want to call this method MouseMove. And it only happens when mouse is set to true. What if mouse is set to false? If mouse is set to false, it'll come down and execute the else code. And instead of listening for the mouse moving, it will window.addEventListener key press. It'll listen for a key pressed on the keyboard. When a key is pressed, it will execute a function called KeyMove. Got that? We've got to make a choice. At the top of our code, we decide whether we want to move the main character using the mouse and have the character follow the mouse, or we want to move the character with the keyboard. The up, down, left, and right arrows on the keyboard, those could also move the character. We can't do it both ways. We have to choose one. If mouse is true, we'll follow the mouse. If mouse is false, we will listen for the keyboard. This is event-driven programming. I want to call the method KeyMove whenever a key is pressed. Speaking of event-driven programming, you might not know it to look at it, but this is an incredibly important piece of code. This is the code that does the animation. This is the code that controls the game. Set interval, MoveIt. MoveIt is a function that we want to call at a refresh rate. So if the refresh rate is 34, it will call the method MoveIt 30 times a second. If the refresh rate is set to 1,000 or 1,000 milliseconds, it will call the function MoveIt once a second. This parameter here, refresh rate, is set in milliseconds. The bigger you make this number, the less often MoveIt gets called. The smaller you make that number, the more often MoveIt gets called. About the smallest number you want to pass here is 17. 17 milliseconds says call the MoveIt function 60 times a second. Since web browsers only update the screen 60 times a second, it doesn't make any sense to go more than 60 times a second. One thing you got to understand about game programming is there's like a heartbeat. There's a heartbeat that goes off. Every so many times a second, we want to refresh the screen. We want to draw the updated screen. Refresh rate is going to determine how often we update the screen. Now, if you don't get it just yet, don't worry. The next slide is actually going to look at these functions. So this closed curly brace matches the open curly brace up here at the top. At the start of our program, since this is on load at the start of our program, this code is guaranteed to run at the very beginning. Basically, what it's doing is it's setting up the game engine. It's loading the needed components, deciding which way it's going to go. Is it going to listen for the mouse or is it going to listen for key presses? Page 3 of 3, the end of the code from this lab. Function MoveIt. Ooh, do you remember the previous slide? Remember how I told you how important this line of code was? Based on the refresh value, I want to call the function MoveIt. If we decide we want to refresh the screen 30 times a second, then this function MoveIt is going to run 30 times per second. If we decide we want to refresh the screen 60 times a second, then MoveIt will be called 60 times per second. We decide refresh rate is going to be once per second. We set it to 1,000. Then MoveIt will be called once every second. That's how you do animation. You keep redrawing the screen. How often this gets called depends on how many times a second we want to refresh the screen. Expect this code, if you leave the refresh rate to 34, expect this code to run about 30 times per second. I boxed in these two lines together because they're very related. What we're doing here is we're erasing the screen. The animation technique that we're going to use in this game engine is to blank out the screen every time. Blank it out completely and then redraw the whole screen on top of it. So we're going to go to canv2d.fill to white. Since our game canvas has a white background, we are going to wipe out the whole screen by drawing white over the top of it. Now once I've set the color to white, I'll do a canv2d.fillrec. I'll start in the upper left corner, which is 0, 0, and I'll go to the width and the height of the canvas, which is the bottom right corner of the screen, and fill that entire rectangle with white. If I change this line to blue here, then it would wipe out the screen in blue. If I change this to black, then it would fill the canvas with black. I add a white here so it fills the entire canvas from the upper left corner, this is 0, 0, to the lower right corner, which is canvas width and canvas height. It fills the whole thing with white. This is essentially an erase command. Erase the entire screen with the color white. Or better yet, erase the entire canvas with the color white. Then we're going to redraw the image. canv2d.drawImage. I want to draw an image on the screen. Remember my global variable where we loaded Mario.png in? Go to the current X and Y coordinate and draw the image on the screen. And that's how game animation works. 60 times a second or 30 times a second, whatever we set the refresh rate to be, that's how many times we're going to redraw the screen. If X and Y has changed since the last time we redrew the screen, this will move the character to a new position. And as X and Y changes, we'll get the illusion of movement by redrawing the image over and over and over again. The underlying concept of the animation with this technique is to wipe out the entire screen, redraw the image in a new place. Wipe out the entire screen, redraw the image in a new place. As X and Y change, our character will move upon the screen. Now, speaking of X and Y changing, how does X and Y change? X and Y changes either based on the mouse. If mouse is set to true, we're going to be looking for the mouse to move and changing our character to that position. This function MouseMove is very related on the previous element, this line right here. Canvas add action listener mouse move. See the name that we passed as the second parameter here? It says if mouse is set to true, call mouse move every time the mouse changes its position. So this only executes when the mouse changes position and mouse move is set to true. It's a very simple method. Y equals event.clientY, X equals event.clientX. See this event? It's what we call a parameter to the method. When the mouse changes position, it will call mouse move and send this event variable. We're simply asking the event variable what is the new Y and X coordinate, and we're updating our X and Y coordinate. When draw image executes another time, if this has changed X and Y, draw image will draw it in a new position. This is why you see the image in a new position. This is what changes it to a new position. Follow the mouse coordinate. Wherever the mouse is, look, the mouse is up in the corner. It's going to return values like 0, 0 for X and Y. As mouse moves down this way, X gets bigger, Y gets bigger. As the mouse moves, these values change. As these values change, X and Y changes, and our character shows up at a new place because of this line of code right there. So that's when the mouse is controlling the game. What happens when the keyboard is controlling the game? Well, that's the function KeyMove. If I back up a slide here, when this code executes, it says when mouse is false, I want to listen for key presses. When keys get pressed, call the function KeyMove. When a key is pressed, it will call the function KeyMove. This code will execute. How does it work? Well, it's looking for 4 keys: the up arrow, the down arrow, the left arrow, and the right arrow. This first if statement says, if the event that caused this to be called has a key code of 38, well, 38 is the up arrow. How do I know that? Because I'm shrinking y. If I'm going up, y is getting smaller on the x-axis. So if I'm going up, I'm going to subtract from y. This line of code, y minus equals speed y, is the same thing as if I had written y equals y minus speed y. Subtract from y 5 if speed y contains a 5, and store the result back into y. This will give us a new, smaller value for y. When we press the up arrow, we want our character to move up on the screen, and that will cause it to move up. Subtract from y, and the character will go up towards the top of the screen. The next key code of 40 is the down arrow on the keyboard. Somebody must have pressed the down arrow. When you press a key, KeyMove gets called. It looks at which key was pressed, and if the code for that key has the value 40, that's the down arrow. If the down arrow is pressed, y needs to get bigger. Y plus equals speed y is the same thing as if I typed y equals y plus speed y. I'm adding to y and storing the result back in y. Well, if y gets bigger, what happens to our character? Our character moves down the screen. When y gets bigger, the character moves down. When you press the down key, I want to move down 5. If speed y still contains a 5, I want to move down 5 pixels on the screen. That's the up and down arrow, as you can probably guess. The next key code, 37, if the key code of the event matches 37, that's the left arrow. I know it's the left arrow because I'm subtracting from x. X minus equals speed x is the same thing as if I had typed x equals x minus speed x. I'm subtracting from x and storing the result back into x. So if x is getting smaller, I'm moving towards 0. I'm moving towards the left hand of the screen. That must be the left arrow key being pressed. Which brings us to the right arrow key. If event.keycode equals 39, does the key code match 39? Turns out 39 is the right arrow. So I'll execute an x plus equals speed x, and I add to the variable x. This is the same thing as if I typed x equals x plus speed x. X is going to get bigger. I'm adding to x. So as x gets bigger, my character should move towards the right of the screen. Okay, I added one little piece of code here at the end. I added this closing script tag. Remember, this is all the JavaScript code. You've got to end the JavaScript with this closing script tag. Now it's time to definitely go over and do the lab. Copy and paste this code in an HTML file, download your image, get this program up and running and working. That is your lab assignment. Play with those variables. Change the speed variables, change the mouse variable, change the refresh rate, and see that it has the effect on the game. In conclusion, let's wrap it up. Remember, modern game programming, you write some of the code, the game engine does the rest of the code. Learning how a game engine works is important to understanding game program. So we're doing it both here. You're going to write the code. I'm going to provide a game engine. You're going to see how a game engine works, and when you're ready to, then you'll start using real game engines. Good luck!